This is lesson 6.1, ratios. The student-teacher ratio of a school compares the total number of students to the total number of teachers. Write the student-teacher ratio of Prairie Lake Middle School as a fraction. Then write this fraction with a denominator of 1. So students to teachers is 396 to 22. We're going to simplify that by dividing both of these by 2. See what we get. We get 198 over 11. Now we actually know that 198 is divisible by 11. So we're going to take 198 and 11 and divide both these by 11. And we get 1, 8 over 1. So the student-teacher ratio at Prairie Lake Middle School is 18 to 1. Can you determine which school has the lower student-teacher ratio by examining just the number of teachers at each school, just the number of students at each school? Well, I don't really think I can do either one of those things. I have to examine the students and the teachers. I have more students at Greenbrier than I do at Prairie Lake, but I also have more teachers. So what I really need to do is set up a ratio, in this case of 510 to 30. Simplify that. I'm going to divide both of these by 10 quickly, which leaves me 51 over 3. 51 is divisible by 3, so I'm going to divide both of these numbers by 3. And what I get is a student-to-teacher ratio at Greenbrier of 17 to 1. So actually, the school that has more students has a lower student-to-teacher ratio because they actually have more teachers. A ratio is a comparison of two quantities by division. Using numbers, I can write ratios 3 different ways: 3 to 4, 3 colon 4, or the fraction 3/4. Algebraically, A to B, A colon B, or the fraction A over B. Ratios can express part to part, part to whole, or whole to part relationships, and are often written as fractions in simplest form. That's basically what we will do for the most part. Fractions in simplest form. And we know from our previous lesson that simplest form means the numerator and denominator of the fraction have a greatest common factor of 1. In our real world examples, seasonings are often added to meat prior to grilling. Use the recipe to write a ratio comparing the amounts of garlic powder to the amount of dried oregano as a fraction in simplest form. I have 4 tablespoons of garlic powder expressed here. I have 6 tablespoons of dried oregano. I write this as a fraction, 4 over 6. I divide by the common factor of 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So the ratio of garlic powder to dried oregano is the fraction 2/3, or 2 colon 3, or 2 to 3. That is, for every 2 units of garlic powder, there are 3 units of dried oregano. Use the recipe to write each ratio as a fraction in simplest form. So I go up to my recipe. I have 2 tablespoons of pepper. I have 4 tablespoons of garlic powder. I have a common factor of 2. I divide both of those by 2. And my fraction in simplest form of pepper to garlic powder is 1 to 2. Oregano to pepper, I have 6 tablespoons of dried oregano. I have 2 tablespoons of pepper. Again, I have a common factor of 2. And I end up with a ratio as a fraction in simplest form of 3 to 1. 3 tablespoons of dried oregano to 1 tablespoon of pepper. Ratios that express the same relationship between two quantities are called equivalent ratios. Equivalent ratios have the same value, same as equivalent fractions. Equivalent ratios have the same value. Determine whether the ratio 250 miles in 4 hours and 500 miles in 8 hours are equivalent. So I write the ratio of 250 to 4. I simplify that by dividing by the common factor of 2, and I get 125 over 2. I write 500 miles in 8 hours as a fraction, 500 over 8. The greatest common factor here is 4. So in simplest form, 500 miles in 8 hours is also 125 over 2. So the fact that these two ratios simplify to the same fractions means they are in fact equivalent ratios. What I could also do is write the ratio 250 to 4 and 500 to 8, and then notice that by doubling the 250 or multiplying by 2, if I do the same thing to the bottom number, the denominator if you will, I do get an equivalent ratio of 500 to 8, which is what I have up here in my example. Again, proving that they are equivalent ratios. Example C, 200 nails for every 5 shingles, written as 20 to 5, divided by the common factor of 5, and what I get is 4 nails for every shingle. In my second example, 12 nails to every 3 shingles, divide both numbers by 3, and in simplest form I get the ratio of 4 to 1. So these are equivalent ratios. In my second example, I'm going to use method 2 up here. If I write the ratio of 2 to 8 and compare that to the ratio of 8 to 14, what I would do here is multiply by 4 and get 8. If I multiply by 4 here, I don't get 14, I get 32. So these in fact are not equivalent ratios. Derek Jeter of the New York Yankees had 32 hits out of 93 at-bats. Jorge Posada had 11 hits out of 31 at-bats. Are these ratios equivalent? Justify your answers. Well, Jeter's ratio of hits to at-bats is 32 to 93. If I multiply Posada's ratio, numerator by 3, denominator by 3, I come up with a ratio of 33 to 93 using the common denominator here, if you will, or the equivalent ratios. These in fact are not, because 32 does not equal 33. A community pool requires there be at least 3 lifeguards for every 20 swimmers, so that's a ratio of 3 to 20. There are 60 swimmers and 9 lifeguards at the pool. Is this the correct number of lifeguards based on the above requirements? Well, if I multiply lifeguards by 3, I get 9. If I multiply swimmers by 3, I get 60. So yes, they are in equivalent ratios, which means yes, I do have the correct number of lifeguards per swimmers. Use the information in the table to write each ratio as a fraction in simplest form. So adults to students. I have 24 adults. I have 180 students. I can divide both of these by 4. I recognize that that is a common factor. May not be the common factor, but I'm just going to get started here. That goes 45 times. I notice that I still have 3 as a common factor. And so what I end up with here is 2 to 15. 2 students, or 2 adults to 15 students. Students to buses. I have 180 students. Again, I have 4 buses. Again, 4 is a common factor. 180 divided by 4 is 45, as I can see from my previous problem. 4 divided by 4 is 1, so my ratio of students to buses is 45 to 1. Buses, 4 buses. To people, that means students plus adults, is 204. Again, I have 4 as a common factor. 1 over 51. So there's 1 bus for every 51 people. This is example 3. Example 4, I have 24 adults to 180 people. Again, that appears to be, no, wait a minute, it's adults to people. This is adults to students, so I have to add my 24 back in here. So it's actually 24 to 204. Again, I have 4 as a common factor. I get 6 over 51. 6 and 51 both have 3 as a common factor. So I can divide them both by 3, and I get 2 over 17. That means there's the ratio of adults to total people is 2 to 17. Example number 5. Determine whether the ratios are equivalent. If I have 12 out of 20 doctors that agree, does that compare to 6 out of 10 doctors? Well, if I divide this by 2, I get 6. If I divide this by 2, I get 6. Yes, they do form equivalent ratios. Those two are equivalent ratios. In example 6, I have 2 DVDs to 7 CDs. Is that equivalent to 10 DVDs to 15 CDs? Here I'm multiplying by 5. If I multiply by 5 here, I get 35, not 15. So no, these are not equivalent ratios. The grocery store has a brand name cereal on sale at 2 boxes for $5. You buy 6 boxes and are charged $20. Based on the price ratio indicated, will you charge the correct amount? Well, if I multiply this by 3 and I multiply this by 3, I actually should have been paid $15, or should have paid $15, not $20, so the answer is no. I was not charged the correct amount. Two vocabulary terms in this lesson. They are rate, which is a ratio that compares two quantities with different kinds of units. For example, cereal boxes to dollars. A unit rate is a rate with a denominator of 1. At this point, you should quit the video, go to my Moodle page, log on, and take lesson quiz 6-1. Remember, your username is your 6-digit student number, and your password is the first 6 digits of your last name and your 2-digit birth